Hi guys, today we're going to walk through this problem that has three parts. Let's start with part A. What is the bicyclist velocity at time equal 10 seconds? Express your answer in meters per second. As we can see, we have a graph of position in meters versus time in seconds. The y-axis is the position and the x-axis is the time. We want to know the velocity of the bicyclist at time equal 10 seconds. We know by definition that average velocity is delta x over delta t. Delta x is the displacement, x final minus x initial, and delta t is the change in time. We see that in this graph, the x-axis is the time. Now let's trace a red dotted line in 10 seconds, and we can see that it hits a portion of the graph that's a straight line that has a positive slope. We know that the slope of this graph, because this is a position versus time graph, we get the velocity. To find the velocity at time equal 10 seconds, we need to find the slope of the graph. I define point 1 to be 0,50 and point 2 to be 20,100. By having 2 points in that line, it is possible for us to find the slope by using the concept of rise over run, as we can see here. It's going to be y2 minus y1 over x2 minus x1, which give us a result of 2.5 meters per second. And we can verify that this is correct. Remember that the velocity for any time between 0 and 20 is going to be 2.5 meters per second. The reason why is because that portion of the graph is a line, and the velocity for any time within that boundary is going to be the same because the slope of a line is a constant. Now let's do part B. What is the bicyclist velocity at time equal 25 seconds? Express your answer in meters per second. So now let's trace a red dotted line. When time is equal to 25, it's between 20 and 30 seconds. P1 for this case is going to be 20,100 and P2 is going to be 30,100. Applying the concept of rise over run, that means delta x over delta t, we get that the velocity for that time it's equal to 0 meters per second. And thinking about this result in detail, we could realize that this makes sense. Because if you see, for example, at 20 seconds, the position of the is 100 meters. At 21, you go check the position is again 100 meters. 22, 23, 25, until 30, it's 100 meters. That means that hasn't moved from 20 seconds to 30 seconds. And of course, when we had 25 seconds, was at rest. And now let's do part C. What is the bicyclist velocity at time t equal 35 seconds? Express your answer in meters per second. I traced the red dotted line at 35 seconds between 30 and 40, as you can see in this graph. The points that I chose this time is P1, 30,100, and P2, 40,0. By finding the slope of this line, we are going to find the velocity for any time between 30 and 40. Because remember that the slope of a line is a constant, we apply the concept of rise over run again, delta x over delta t, and we get that the average velocity is negative 10 meters per second. Remember that velocity is a vector, and it is negative because we are finding a negative slope. If we adopt standard conventions, negative velocity is going to the left and positive velocity is going to the right. And we can see that this is correct. Now, as a clarification about the axis, some people wonder why I use y for delta x and x for delta t. The reason is that in this graph specifically, the y-axis is x in meters and the x-axis is t in seconds. Then when I do delta x over delta t, to avoid confusions, I use the y and x-axis convention. That means that delta x is going to be y2 minus y1 instead of using x. Delta t, instead of using t2 minus t1, I used x2 minus x1. This is going to the standard coordinate plane convention. Okay guys, I hope that you enjoyed this video. Like it if you like it, hit that subscribe button, share this with your friends, your geek friends, your girlfriend, your cat, your dog, and anyone who needs physics for life, love, or for college or whatever. Okay, I'll see you guys. Keep it going and keep the good study.